Testing. Okay, cool. Testing online. Can you hear me? Can you hear me? Testing. Testing. Can you hear me? Testing, testing, testing for online. Online, can you hear me? Can you hear me? Testing. Testing, can you hear me? Testing, testing, testing for online. Testing. Okay, our lecture will start in 3 minutes. So in the future, all of our lecture will start from 6:05. So this is to accommodate for students who have another lecture before this one. So we allow some time for them to travel from another lecture to this lecture theater. So today's lecture will be the same. It will start in about 3 minutes. So feel free to have a chat with people next to you, and we'll get started at 6:05. Is anyone celebrating the Lunar New Year today? I think it's the Lunar New Year's Eve, right? Yeah. Yay! Thank you so much for coming today, actually. I didn't expect so many students to be here. Do you have any plan after the lecture? Yes, no, no time for that. Anyone from online? Do you have any plan for tonight? What's your plan? A big dinner?
Big dinner.
Oh, nice. So what's your traditional food for Lunar New Year's Eve?
Maybe
Dumplings? Yeah. I know from different parts of the world, people celebrate Lunar New Year differently. They have different type of traditional food. So dumpling is one of them. Is there any different ones? Or are you all having dumplings tonight? Like I think some people are having like the balls made of noodle and they kind of fry the noodle balls, right? And other people, I talk with people and they will have fish for the Lunar New Year's Lunar New Year's Eve, sorry. Yeah, so Yuan from online said that they were having dinner with friends. Yeah. Anyone's having like videos with their families from overseas tonight? Like say Happy New Year. Yay, Happy New Year. Okay, cool. Amazing. Now it's 6:06 now, so we are a little bit over, like 1 minute over. So this lecture is about software project management. So you may have known that this is a new course. So in the past, our postgraduate students take the GSOE 9820. But from this term, we are going to have a new course, which is for like Master of IT or software information system related students. So the reason that we are having this new course is because in the past, we have got feedback from students or from industry people and saying like people graduate from those degrees, they lack of the knowledge on this specific management, not just very broad general engineering project management, but more about like software or IT system project management, so more specific skills. So this is the reason that we introduced this new course. And also, because it is a new course, it's my first time teaching this course, designing this course. So I'm hoping that you really enjoy this course. I love the topic. This is a very, very important topic. Like software projects are huge. You know, like in industry, like for Atlassian project, for YouTube project, for Netflix project, those projects are huge, right? So how can we manage those projects? It's a very important topic. This is not just only important to those project managers, but all the developers, everyone on the software project team should know about this. So this is why I think this is very important. Okay, so let's get on to the topic. Welcome again. I know I sent an email last week saying welcome, and also I posted an introduction about myself on the forum. So now just a very brief introduction about myself again. So I'm Dr. Yuqiao Jiang, so this is my name. You can just call me Yuqiao. I'm a senior lecturer at the School of Computer Science and Engineering. I had my PhD in software engineering. And now my research is about education for software engineering. So I'm an education-focused lecturer here at UNSW, which means everything I do for my work is about education and education for software engineering specifically. So that's me. And we also have 12 fantastic tutors for this course. They are from very diverse backgrounds. So about 1/3 of them are from industry, like who are working in industry as a software developer or in software companies. Another 1/3 of the tutors are like postgraduate students like you, but they are quite close to finish, and they had learned the skills that we are teaching in this course, although from like their own maybe personal learning experience, but they know exactly what this course is about. So they have very recent learning experience as you, so they know how it looks like learning those concepts and skills. We also have another 1/3 of tutors who are like learned those skills and topic from their undergraduate courses. So there's some topic in this course, for example, Git, like version control. So these are topics that we also teach in undergraduate courses. So some of our tutors are from like tutors from those courses. So they have experience teaching those topics that we learn in this course. So our tutors have very diverse background, and we also match them in pairs for each class. So each class will have 2 tutors. So you will have a diverse set of like people with different expertise to help you in this course. And we also have you. like the most amazing, fantastic you. So thank you so much for everyone who introduced yourself on the forum. If you haven't got the chance to do that, feel free to do that at any time when you have like, have 5 minutes, I don't know what to do, then introduce yourself on there. And try to interact with other people, make friends with each other, networking with people. Okay, yeah. So how about we make good use of today's opportunity to get to know more people in your cohort? So how about we talk with people on your left-hand side and ask them, what's your name? Which degree are you taking? Like, what do you expect from this course? Anything, have a chat with people next to you. If you don't have people sitting to the right, you can also talk with people sitting to the left-hand side. 2 minutes. Or people online, feel free to introduce yourself in the chat. Alrighty, time. I know 2 minutes is not enough, but I hope that's a good starting point for you to networking with students in your same cohort, and you can continue that conversation after the class, okay? So now, who wants to introduce your friend sitting next to you? Hands up if you want to introduce the people who are sitting next to you to the rest of the class, not yourself. Hey, hey, hey. Let me see who is brave. Do we have anyone who is brave? Yeah, great, amazing.
My new friend right here, her name is Mercy. She's
Mercy?
from Uganda, and she's almost finishing her degree. So that's
Wow. Last term, congratulations, Mercy. Thank you. Thanks.
Thank you.
Anyone else? Yeah. Sorry. Very similar experience and background from you. Oh, great. Sorry, what's your name? Sorry, what's your name? Sonnet? Zhelin? Yeah, how about your friend's name? Guang Zhiyuan. Oh, nice to meet you, both of you. Amazing. So let's continue these conversations during the break in the middle. So we are going to have a break. So we are going to have a 1 hour lecture, 5 minutes break. Feel free to use the toilet, have some water, have some chat, and then we'll come back for another hour. Okay, so let's continue this conversation, getting to know people, and yeah. Okay, cool. Back to the topic. Why are we here? So why are you here? Is it because it's a core course? we have to take? Yes and no. So if it's not just because it's a core course, but you are just taking the course, so why are you here? Or like, although it's a core course, right, we have to take it, but what do you want to get from it? Like, why are we here? Like, what do you want to learn from it? Industry experience. Fantastic. What else? How to work with groups? Wow, that's a big topic. Anything else? Or you just want to figure out what this course is about? Cool. So we will have some, like, not real industry experience, but we'll try to simulate some industry experience or teach you some skills that you will need for your future industry career. And we will definitely also learn about how we can manage groups, how to lead a group from diverse background, how can we manage software projects. So why software project management matters? Okay, so here are some questions for you. I assume all of you have some like coding background because it shouldn't be your first term, and you have learned some like coding programming. So let's have a look at those questions. Have you ever tried to fix a bug in your own code only to break something else? Have that happened to you? Yeah. Now imagine working with millions of lines code. How are you going to manage that? Right? Second question, imagine working on a huge team. How do you keep track of who changes what? Right? Very important things to answer, to think about. Next question, why do apps like Instagram, Spotify, or Google Doc get updates every few weeks? It's very common, like when you open a computer, open the app and say like updates needed or new software updates. It's very often. Why? The last question, what happens if a banking app miscalculates transactions or a self-driving car misinterpret data? Wow, that was so bad, right? So how could we manage our software projects to avoid that to happen? How to manage it properly so we know who changes what, what's going on there, and making sure there's less bugs in there. So this is what we will try to answer in this course, and why this is so important. What we are going to learn is how to manage from small projects to big impact. So in the past, you may have some small student projects where you write a small game or class project. It works, you submit it, that's it. You never touch the code again, right? Like throw away that code. And no one else needs to maintain it and bugs will matter after submission. That's it, that's finished, that's the end of the project. However, in the real world, when you work in, for example, Atlassian or like Google, your code will be used by real people, right? And other people in your team will build on top of your code. Other people will need to maintain other people's code. So how do we manage all of this? What if your program has millions of users, it needs to work on different devices and to be secure? If something goes wrong, the company loses money or worse, people get hurt. Okay, so cool. Any questions so far? Like, why are we here? What we are trying to get from this course? What we are learning? Yeah, question.
So we are here to practice code? Have some practice.
The question is, are we here to practice some code? That's a really good question. So, yes and no.
Yes or no?
The reason that I said no is because the course is not a coding course. So we do not teach programming. We don't teach coding. We assume that you already have that knowledge from courses like 9021 or 9020 or something equivalent, maybe from your experience, past like working experience and others. So this is not our focus. We do not teach coding or programming. It's not about management, but here we talk about how do we manage the code base. Like, it's not a small personal project, but more like a big project. Like, how do we manage it? When it has a lot of code, when there's a lot of people working on it, how do we manage the project and the people?
So actually, we are learning to how to be being a manager.
The question is, are we here to learn about management? Again, yes and no. So everyone on the team working on a project should be responsible for that project, not just the manager. So everyone should be responsible for the project. So everyone should know what they should do to make sure that the project is going properly, like the code is safe, there's less bugs and stuff. So you can, of course, there will be a leader for each team. And you can rotate the role for leader in your group, and you can practice how to lead a software project. But that's not the only thing. Like, you also learn how to be a good member in the project, to manage the project collaboratively with others. So this is what we are going to learn. Is that answers your question?
Yes.
Okay, cool, amazing. Any other questions? Yeah.
We're gonna work like in industrial where we have one PM, maybe two software engineer and two PA, so we can like split our job on different people, or each people will become their own PM, their own software engineer, and their own PA.
The question is, will we rotate the roles throughout the term? Is that right? My suggestion is yes. So everyone on the team get a different experience, because during the course, during the 10 weeks, we are going to have one project, and it's divided into 3 sprints, like three iterations, like 3 sprints, like divided into 3 parts. And you can rotate your roles when you change the sprint. So for example, sorry, what's your name again? Mercy. So for example, Mercy acts as the leader for the first sprint. And then in the next sprint, so Zerlin can volunteer and say, I wanted to be the leader. But there are different roles. So I'm just making an example and saying you can rotate your roles. Any other question? Any question online? Okay, so to be able to know how to manage big software projects, the first thing is to understand the software process. So you know how you can actually manage it, because software development is a very big thing. Like, there are a lot of things involved in a software process, right? So we are going to have a brief introduction on how's the process, and then we'll going through all the stages in more details later in the term. So today is just a very overall introduction to the different stages, and then we'll go through them one by one in the following weeks. Oopsie. Cool. So, question?
I'm jumping the gun here with this, but just curious.
Uh-huh.
It's a software project management class. Do we have a final that is written, or is it, since it's a project management class, it's basically cumulative?
Sorry, can you repeat your question again?
So my question is, I know that I'm jumping the gun to ask about the final, but since it is a project management class,
Uh-huh.
is the final project-based, or is it written that regard?
Yeah, no problem. So your question is about assignments, like whether it's a final, is that right?
Sorry?
So we don't have a final exam. Yeah. We don't have a final exam in this course. The only assessment in this course is a project. That's it. So everything finishes by the end of week 10. Nothing beyond week 10. That's it. Yay! I hate exam as well. I know how stressful it is. Cool. Okay. So why do we need to know the process? Because we wanted to have some logic. So we want to know what's going on next, right? So when you manage it, you need to plan it, right? So you need to make sure that you are on the right track. So to know the software process will help you be more efficient. Like you know the work is done in a logical and step-by-step manner. And it's also predictable. You know what's going on next. Right? It also helps with quality insurance. You know you are maintaining it, you know you are writing some maintainable projects so that in the future you won't go back and say, oh, why there's a code like this? I don't know why the code is here. Right? It's like building a house. You need to have a plan first. You need to know what's going on here and there. So this is why we need a software process. So the process has different models. So the most traditional one is called waterfall model. A waterfall model is very linear, it's structured. So you need to finish step 1 so that you can start step 2. Once you finish step 2, you can start step 3. So that's called the waterfall model. So let's have a look at this waterfall model first. So there are a few stages in the waterfall model. The first stage is about gathering the requirements. So for example, your client give your company or your startup or your group a task saying that, can you please develop a software for timetable management? What's your question next? So you may ask, what do you mean by timetable management? Right? So what do you want in this project timetable management app? Or what are the users for this app? Right? So you need to ask them these questions to understand their requirement before you start actually coding anything. Right? So this is called requirement engineering or requirement gathering. So in the traditional waterfall model, so this is the first step. You need to gather the requirement first. And then when you know who are the potential users, what are the use cases, like how the users are going to use this app or like software product, you start to design the overall system. It's like the house. Are you going to have just one flat layer, or are you going to have some stairs to climb up? How many rooms are you going to have? Are you going to have a kitchen? Are you going to have a toilet for your house? Right, so you are going to do this overall design for the house. So this is the step 2, which is the system design. And then when you say, well, I'm going to have 3 bedrooms, 2 toilets, 1 kitchen, and 1 laundry. And then here are they are going to be here, 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 and here. And next step will be you implement that house. You implement that code, you write that codes to achieve, well, here's the laundry, those are the blocks. Right? So I built the laundry, the kitchen, the toilet, everything. So that's the implementation. And then you're going to make sure that the house is safe. It meets with the client's requirements. Everything works, the toilet works. It won't stuck very easily. Right? So you are going to do some testing. So similarly with your code product, your software product, you're going to do some testing too, checking everything works. And then the house is just a house standing there. People need to use it. There should be people living in there and using the things in the kitchen, right? So this is called deployment in our software projects. So you need to deliver your code to the users so that your users can use your application. So the code or your project not only sitting on your own laptop, but other people can use it. How can we do that? So that's called deployment. And the final step is called maintenance. So once your application, your software is ready for people to use, people may report, well, like the toilet most of the time it works well, but still occasionally it's like not functioning properly. Can you fix that for me? Like you need to maintain that house. And similarly with our code projects, like software projects, you will also need to maintain your software project. People may report, well, there's a bug. Can you fix that, please? Or people will say, I need this new feature for my timetable management application. Can you add that feature for me? Right, so this is called maintenance. So these 6 stages are the stages for traditional waterfall, not traditional, but yeah, traditional waterfall model process. So those are the stages. But have you heard the term of agile? Yes? Some yes, some no. So agile is a more flexible way of managing our software process. So it doesn't necessarily have to be like the requirement gathering is perfect, and then we can start the design process. And not that like the design process is perfect, and then we can start the implementation. So agile means like faster turnaround, caring more about like workable software, not like documentation. So this is because people notice that like nowadays the tech world is changing so fast. And if we have a great idea and we just stuck on the requirement engineering phase and never start working on implementation and everything, and other people will do it, right? And people's ideas, people's needs will also change. And they also notice that the requirement can never be perfect. Like, there will always something. Or when they start implementation or designing or testing, and they found that some of the requirements they gathered at the beginning was not correct. So this is very common. So nowadays, more and more people are using agile way to do their software projects. Means that there's more flexibility. It's not like waterfall. Like you can always go back, just like more iterations. This may sound a little bit vague to you, but we'll get to more about like agile in the later weeks. But here we are just giving you a very overall information about what are the stages in software process and the traditional waterfall model, and a very high level introduction about agile. So agile is not about a methodology, but more about a people's mindset, like how people think about software management or software process. Any question? Confused? Or is it all good? All good? Okay, cool. Online people, if you have any question, feel free to put in the chat. Okay, I'm monitoring the online chat as well. So Agile is a software development methodology that emphasizes flexibility, collaboration, and continuous improvement. So collaboration here not only means collaboration with your team member, but also collaboration with other stakeholders. For example, your client. You keep updating your clients, your progress, anything you have got, get feedback from them, asking questions, anything. And you also collaborate with, for example, experts in the field. For example, if you are building a clinical application or clinical software, right? So you want to get a clinical experts involved in the design process, like the whole process as well, because there may be something you don't know. There may be some privacy concerns. There may be special requirement from like the clinical background or things. So collaboration means much broader than collaboration within your team members. So it's based on the idea that software development is a process of continuous learning and improvement. Amazing. Any questions so far about the general process? So we will follow this process in our project as well. So you will have a chance to practice all these stages in your project in this course too. So we will go into more details into each of them. All good? Yep, question?
Can you explain more about
This, can I explain more about this modern approach? Yeah, sure. So this modern approach is called Agile. So the difference between Agile and waterfall model is, for waterfall model, you need to complete one stage so that you can start the next stage. For example, you need to finish. You say, done, this is done, like completely done. The requirement gathering stage. I think my requirements are perfect. I've got everything my clients need. I know exactly what I'm going to build. And then you move on to like design the overall structure of your software. Like I'm going to have 2 bedrooms, 1 toilet, or whatever. So if you haven't finished requirement gathering, you can't go to the next stage. So that's like traditional strict waterfall model. But for Agile, it means more flexibility. It emphasizes like continuous improvement. I may have an MVP, like it's work. I may have some code written to achieve some of the requirements. It may not be perfect. It's okay, but it's functioning. And I show this product to my clients, stakeholders, potential end users, and ask questions like, how do you feel about this one? And then continue improving. So similarly with testing and maintaining everything, so it's more iterative rather than linear. But it's more about mindset, not just the process and approach. It means that we are continually improving the projects. It's never done. Yeah, and never aim for like a lot of documentations, but more about working software. Okay. No problem if you are still confused. I know I'm only introducing a very high-level, general concepts, but we'll do the project. We'll have some like practice using the methods and process, so you have better understanding of what it means. Okay, all good? Cool. Before we move on to the next topic, where we are going to answer the question at the beginning, like one of those questions at the beginning, which is how do we know who changed what, how to keep track of the code, how do we go back to time machine to go back to a previous version of the code, like how do we collaborate and manage our code base. So that's the question that we are going to answer during the rest of today's lecture. But before that, I'm going to talk about some general stuff. So in this course, we'll form groups. So as I mentioned earlier, there's only one assignment in this course, no final, no quizzes, no lab, only one assignment. Yay, I know. Only one assignment, which is the project. So we'll form groups to design and develop software projects following the software project management practices. So the groups will be formed in your week 1 lab. So please join your week 1 lab. In case you can't join it for whatever reason, please email your tutor and telling them like you are not dropping the course, you are still in the class. Please give you an allocation, like a space of spot in one of the groups, letting them know. And then the course will not teach web development or coding. So this is very, very important. This is not the focus of the course. I know there's no like required prerequisite for the course, but like coding or like web development is not the focus of the course. So you are suggested to take the course after finishing at least COMP9820 or something equivalent, or if you have any background like from your personal career or work experience, you know how to code program. Great, perfect. You do not have to finish the course, but you need to know something equivalent. You need to have the knowledge background. Otherwise, it will be very, very challenging for you. I'm not saying that you can't do the course before having those coding experience, but it will be very, very challenging for you. Yeah, so if you haven't completed 9021 or something equivalent, we recommend you come back to this course at a later stage. So I think I need to tell you this to you as early as possible so you can plan ahead. Okay. There are other things that I wanted you to know like some UNSW services like health and well-being. So UNSW provide a lot of service about that, like students' health and well-being. So at any time you feel like, oh, I'm too stressed, there's too much homework, I'm taking too many courses, I'm not feeling well, do not struggle yourself. UNSW has a great service for that to help you to get through those. Another thing that I want to make sure that you know of is the special considerations and short extensions. Are you aware of special consideration? Do you know? Yeah, so for anyone who doesn't know about special consideration, have a look at that. So for example, if you are in hospital or like, I don't want it to happen, but just in case there's something happen during like 1 week of your one sprint, you cannot contribute to your project, you can apply for special consideration. And when we mark, we'll take that into consideration as well. So we will assume you have less time to do that sprint. So when we mark, we'll take that into consideration. Okay, so your well-being, your health is the priority. Right, so this is always the priority. Cool. Another topic, ChatGPT and other generative AI tools. So I always get this question, like, can we use like AI agents to support my project? What do you think? Yes. To what extent? Yeah. So because this is not a fundamental course, and it's not a like we're not teaching very, very fundamental things. So I don't want to be too strict about using those tools because I'm also using those tools. I know those tools can sometimes be very, very helpful. And sometimes when you go to industry, they will also ask you, like, do you have those AI literacy? Right, so I think this is also a very important skill to learn. But I want to make sure that you are using those tools properly. So by properly, I mean you are not using those tools to complete your assignments, doing your job. So as you mentioned, like, I'm happy for you to use those tools from research purposes or learning purposes. But you need to know what you are doing. Right? So you need to be able to explain why you are doing what you are doing. And you will need to acknowledge your use of these tools in your submissions. You need to acknowledge how you use those tools for which specific part of your submission and why. Like, you need to justify how you use that. And you need to be able to explain your project, like why you make that decision, why I want to have that feature, right? Like, why do I design that feature to be like that? So we are going to have project check-ins throughout the week. So, so tutors may ask you questions about those. Okay, all good? Cool, I hope that makes sense. Cool. And there's no exam, so. ELP, so if you have a registered ELP, I will reach out to you individually either this week or next week to let you know what adjustments we make for you in this course. Yeah, so and I wanted to thank you for your patience in advance. Because this is a new course, so almost every piece of the course is designed from scratch. Some of the materials I student from another course, which I taught in the past, which is the software engineering fundamental for undergraduate students. So there are some like overlaps in the concept. So I got those materials from my previous course, but the majority of the material in this course are designed from scratch. So I may not be able to provide you with all the slides for all the 10 weeks. So, and all the material for the rest 10 weeks. So I'm releasing it gradually. So thank you so much for your patience in this process. And I know it's not perfect, although I hope it's perfect, but I know it's not going to be perfect. So for any of the material components of the course, you feel like, well, this can be better in this way, let me know. I'd love to hear about that. Or I feel like, oh, this doesn't make sense to me, let me know. I'd love to know like why it doesn't make sense and how we can improve it together. Yeah, okay, so general stuff. So at the end of each topic lecture slides, you will see this QR code. Feel free to scan it, and we ask you for feedback on the lecture, the lab sessions, and the project, and anything else. So if you have any feedback for you, I would love it. I really love feedback. I hope the course is perfect, but yeah, I'm hoping to improve the course together with you. The lecture slides are all released on here, will be released here on the course website. So you'll notice that there are already 3 slides uploaded, which are the 3 topics we are going to talk about today. I'm not sure if I can finish it today because I'm feeling I'm talking too much, but I will try. But I don't want to rush too much. If there's any topic that we can't finish today, we can continue next week, so no problem. So for each week, I'll break down the slides based on the topic. You can also find the YouTube live stream link here on the course of it as well. The recording will also be on YouTube. For YouTube recording, there may be one concern, like there are some advertisements. So this is something that I don't have control of, so I can't remove the ads from YouTube. So if you prefer to use the YouTube recording, click on that link. What I'm going to do is I'm also going to provide a recording on the SharePoint, like UNSW SharePoint. No advertisements for sure, but like the accessibility is not as good as YouTube, but you can choose which one you want to use. I'll provide you with those 2 options. Okay? Amazing. Okay, let's get started with this one. So remember the question that we asked at the beginning, which was here. How do you keep track of who changes what? What if you break something else? Like how can you go back to use the time machine to go back to another previous version, right? Yeah, so this is the questions that we are going to answer in this next topic, which is called version control. So talking about version control, what are you thinking about? Sorry? Huh? Saving the code? Yes. So how are you going to save the code? Yep. So for anyone who don't know GitHub, imagine just know GitHub. Are you going to save your code using Google Doc to collaborate with other people? Are you going to have like multiple versions, like you have code version 1.1, code version 2.0 or something to control the version and take notes of like what is this version 1.1, what is that version 1.2? Is that what you are going to do? Or are you going to use, for example, Google Drive to collaborate sharing codes with others? Right, so those are also version control actually, right? But it's just not that convenient. It's so complicated. It's not designed for code version control, but more for like documents, right? So this is what the problem that we are trying to solve. Like, how can we control the versions of code? How do we manage our code? And how can we have multiple people to working on the same piece of code? It's so common, right? So maybe we are implementing the same feature like user login. Everyone on the team is working on user login. How can you collaborate the code on the code when multiple people are working on it? Google Doc. Is there a way that can be more efficient when it comes to code? Git. So Git is the solution. So you may have heard like GitLab, GitHub, Bitbucket. What are they? So fundamentally, they are all Git. So fundamentally, they are all the same thing. So Git is a version control tool that enables people to work concurrently on the same code base. Git is a program just like VS Code, GCC, and others. But it's built specifically for programmers and designed for managing code across lots of people. And it has a very detailed history. Still quite vague, no idea what is it, no problem, we'll have a look at the details. And more importantly, Git is a distributed version control software. Means that you can have multiple people working on different laptops, but you are collaboratively working together. Okay, still so vague. I know, this is so high level. So what I'm going to do next to show you how Git works and what exactly is this Git. I'm going to do a lot of demonstrations for the rest of the lecture. I'm going to show you how Git works and how Git helps you with managing your software projects. Okay. What about we take a break? Okay, let's have a break for 5 minutes. Let's come back at 6:56, roughly. Okay, have a break and we'll start the demonstrations. Hello, hello, hello. Hello, hello, welcome back, welcome back, welcome back, welcome back, welcome back. I know 5 minutes is very, very short, but we do have a lot of things to cover, so I had to call you back. During the break, I got a lot of questions, and almost all of them are about the assignment. So I think it will be a good idea for me to answer the questions as a group for all of you, so you know what kind of questions were asked. Maybe you also have that question in mind. Okay, so since we have so many questions about the assignment, so let me just quickly go through the assignment. So on the course website, you can see this assignment overview. So the project will be divided into 3 sprints. So the first sprint will be due on week 4 Monday, and then week 7 Monday, and then week 10 Friday. So at the end of each sprint, you are going to get some feedback from your tutor. So you will not be surprised, you will know how you are progressing. Further than that, for the first sprint, or all the other sprint, I will also release the project guideline by stages, which means, for example, for here sprint 1, there's already a guideline, like initial guideline for sprint 1 on the course website. Let me show you. So what I'm going to do for each sprint, I will give you a weekly planner for each sprint. So you know what to expect for that week. So you know whether you are on track, so you can plan ahead. So as long as you are on track for that one, you are not like falling behind. You can have a look at this later, so you can use your lab time to read through the details. But another question that I had during the break is how can we make sure that you are because everyone has different expectations, like time availability for the course. So we do have some group marks and individual marks for each sprint. So this is the example for sprint 1. But then for sprint 2, group mark, individual mark, sprint 3, group mark, and individual mark. Because this is a group project, so we expect you to support and help each other. Like think of your group like a startup. You want success as an individual, right? You success as a startup, as a company. So we are a group. So we learn from each other, we support each other, we help each other, right? We learn from each other. Right? So some people may be more talented on coding programming. Other people may have more talent on, for example, managing conflicts or other things like planning, task allocation, or other things. So as long as you are doing your best to contribute to the project, that would be great. Right. But some people may ask, like, how about I don't code at all in this project? Like, am I going to get some marks? So you need to code, unfortunately. Like, everyone needs to code, so you know how to manage code. If you don't code, how can you know how to manage code? Like, how do you manage code conflicts if you don't code at all, right? So, so this is about that. Another question that I got during the break is about the group numbers, like how many people per group. Each group is going to have 4 to 5 members. And we have randomly allocated groups for equity reasons. So we don't want like have some very strong groups and very weak groups. That would be like not that good. So we randomly allocated groups for you already. However, if you have any concern about your group, please let your tutor know during your week 1 lab. We will figure things out for you. Your tutor may also have a look at your background in your week 1 lab as well, may shuffle your groups around, that's possible. We also have some principles that guiding the group formation. For example, no single girl in any group. So any group will have either no goal or more than one goals. But if you're happy, like I'm okay with me, just myself as a single girl in that group, that's also fine. But we want to make sure that you are okay with it. There are other principles to get the group formation as well. During your week one lab, have a look at your group, any concern, let your tutor know, and we'll figure things out for you. Do not wait till like spring 2, spring 3, and then raise your concern. Raise concern if you have any as early as possible, so that we can help you as early as possible. Okay, another question that we got about the assignment was about the project topic. So to make sure that we can get started straight away or as early as possible, we give you a topic that to start with. So you do not need to struggle, oh, should I do this project? Should I use that topic? So we give you a topic which is about this story. So I just made it up. So have fun reading it, but in overall it's about task tracker. So you can add a task, delete a task, edit a task, allocate a task, put a task to different stages or whatever feature that you feel like having. So this is the project spec. In your GitLab, so everyone should have a GitLab repo set up for you already. So we have already done that for you. And you should have something in your repo already. For example, for Adihi, so there's 2 repos created for you already. One is the lab Git. So this is a step-by-step instruction or lab helping you to set up your GitLab, practice using Git and everything about Git. So the lab is not marked. Do not worry about that. So the lab is only designed to help you practice and set up your GitLab. Although it's not marked, I strongly encourage everyone to do that because it's super, super important, super, super helpful for your future career, for your project in this course. It's very important. Yeah, question?
So for the project topic that you mentioned, is that going to also carry on to the other sprints, or is that just for sprint 1?
The question is, for the project topic, will this be the project topic for sprint 1 only, or will it carry over for other sprints? The answer is, this is the topic for your whole project. So different sprint will have different focus. So for example, sprint 1 is, you can have a look at here actually. So each sprint will have a different focus. So sprint 1 is mainly about setting up the foundations, having the first flight, like practicing Agile team practice principles, collaboration, blah, 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 and translate your ideas to user storage, which we will talk about that in week 3. Do not worry about that if you don't know what that is yet. And establish good Git habits. At the end of the sprint, each group should have a functioning project structure. Blah, blah, blah. It's mainly about setting up the foundation, get the project, kickstart the project. So this is about the sprint 1. And sprint 2 is more about like more tooling for project management, like how there's one thing called pipeline. So this is a tool that helps you with some like automatically manage your project to some extent, and other tooling as well. We also learn about deployment, like how to make your project available for other people to use. So that is about sprint 2. And sprint 3 is more about like, I want to do something that I'm interested in. I'm more interested in learning about like sessions, users, registration, other things. So we have more flexibility in sprint 3. So each sprint will have a focus. For now, you only need to worry about sprint 1, which is getting started. So sprint 1 is the easiest marks to get in the whole project. So sprint 1 is the easiest marks. Sprint 2 a little bit harder, a little bit more challenging, and sprint 3 will be the most challenging part. It's like getting more and more challenging, but sprint 1 is more about like getting started, the foundations. But the whole project is the same topic. Any other question? Oh, we haven't got started on Git yet, but it's okay. Question? All good? What was the other questions that you asked during the break? I think I kind of mentioned everything. Oh, there's a question online from Troublemaker. Hi, just wondering if cloud and or might be covered in the course. Unfortunately, those are not the focus of the course, but feel free to learn it on yourself. Sorry. Any other question? Yep. The question is, do we have a schedule for the lab? The lab one, this one. Where can you find that one? I'm working on a newsletter that will be sent tonight, so I will give you the link. But if you go to, I don't think you have a link yet. I'll send everyone the link. I'm preparing the newsletter. So from week 1, from this week, I'll send weekly newsletters about things that you need to know for that week, like things to be get done for that week. So I'll send weekly newsletters on every Monday. Yeah, question? When are we forming the groups? During your week 1 lab class. Yeah. Make sure you can go to your lab class this week. Very important. Other question? Yeah.
Does we randomly select or just form a team with our friends?
How do we form the team? Is it randomly or do we form the teams with friends? Yes. We randomly form the teams for equity reasons. Yeah. But you will know your group during your lab 1 class. If you have any concern with your assigned group, let your tutor know and we'll figure things out for you. Yeah. All good? All good? Okay, cool. Let's get started with Git. Okay, so can anyone tell me why do we need Git? Why are we learning it? To keep track of everything. What else? To manage your program, project? Yes, for sure. Anything else? And also for concurrent programming. Means like working on the same code base at the same time with other people. Okay, so this is why we are learning Git. Okay, so let's get started. So, to learn Git, there are 2 ways to interact and use Git. One is through terminal. Do you know what terminal is? Yes? Okay. Yeah, and the other way is through some GUIs like GitLab, GitHub, Bitbucket. So fundamentally, all these 3 things are just Git. It's the same as how we do it through terminal. But it just provides you with some interface that you can use to use Git. So today we are going to use both ways to use Git, so you know what Git is and how it helps you with your project. Okay, so first of all, what I'm going to do is I'm going to create a project. So I'm start a project first on GitLab. So our project will be on GitLab, not on GitHub, not on Bitbucket. So you can also go to your GitLab through http://gitlab.cse.usw.edu.au. So you will be able to see something similar as what I see here, but you may have less things here because you just started on your GitLab. And then on the top right, there's a plus icon button. Click on that, you can create a new project on GitLab. Let's create a blank project, starting from scratch. And let's name this project. How should we name this project? How about just welcome 9820, okay? So this, name the project, and you will also need to pick like where your project is located. So you need to give them like, it should be on this folder and that directory. For me, I'll just put on under my personal one. So you can also do the same. Put your ZID here, and then you can select like visibility level of this project. Either be private, means that people will need to be granted access so that they can view, edit, or manage this project. You need to grant them access. For internal, it means that the project can be accessed by any login user except the external user. So anyone can log into this CSE GitLab, can have access to this project. So I'll put it as internal so you can have a look at my project later. And then I'll create this project. Amazing, so now I have a project now on GitLab. Perfect, yay, first step done, yay. Okay, so, but normally when we code or program, we don't do it on web browser, right? We use Visual Code Studio or other like code editors that you prefer. So how can we make sure that we have this project locally as well? So the way we do that is, I already have my Visual Code Studio ready. So what you can do is you need to clone your project. So git clone means you are copying the project from GitLab to your own laptop, your own computer. That is what git clone means. Clone, like you have that project, the same one on your computer as well. The way that Git knows which project that you wanted to clone, which project you want to copy, is through this here. You can click on this, it will copy the URL for you. Click on that button, copy it. And then what you can do is open a terminal, go to the directory that you wanted to clone this repo to. Go to that directory. So for me, I think I'm at the right directory. Okay, perfect. There's, no, what did I do? Sorry, I need to go to the directory again. I accidentally used CD. Sorry, 1 second. I'll find my repo. Where is it? Lecture demo. Get info. Copy the path name. And then CD here. Okay, cool, amazing. Then I'm going to the directory called lecture demo. I'm going to git clone that repo to my lecture demo directory. And what I'm doing here on my terminal, the command that I'm going to use is called git clone, and then copy this one, pass it here. It's called git clone. Can you see clearly from the back? Is it all good? What about the back? All good? Everyone okay? Okay, perfect. Let me know at any time that you can't see clearly. I'll make it larger, okay? It will ask you to enter the passphrase. So I can git clone properly because I have set up my GitLab. So if you try it now, it may ask you asking for fingerprints and other it's like key password. It will ask you for that. You may not have that yet. To set up your GitLab, follow the lab git. It will help you. It will guide you to set up your GitLab, and you can do git clone. So now I have git clone. Let me see. Now I have this project here. In this directory, it's cloned here. So let us have a look what's in there. So cd welcome. It has one file which is called readme.md. So this is a markdown file. It's called readme. So it's exactly the same as what we have on GitLab. Is everyone okay so far? Like, do everyone know how to use terminal? Who knows how to use terminal? Okay, cool. Relieved. Okay, cool. That's great. So you should be on track. So any questions so far about GitLab? So what we just did was we created a new project on GitLab. So this is a platform. You can think of like a Google Cloud. You started a project, you started a Word document, a spreadsheet there. But now it's a like code project, a software project. But the project was remotely on GitLab. It's like at their server, it's not on our own computer. But we want to work locally on our own code editor, such as Visual Code Studio. So we need to have those locally. So we copy that project locally, and the way we do that is through git clone. And by telling them which project to clone from GitLab, we give them the copied as URL, this one. All good? Okay, cool. So now you can open your own like favorite code editor, for example, like Visual Code Studio by doing that. But for me, my computer is not working properly, so I'll open it from here. So now you can see, well, this is the only file that we have in this project, and we have cloned it locally. So here it is. It is the README file. And now we can start playing with it. So for example, I'll have something called, how about just git.md. So md file means markdown file. So it's not like a code that you can run. It cannot do some like, you cannot run it, just displaying some data, some information for you. It's like text, like .txt, but it's more formatted. Okay, so what we have learned so far, we have learned git clone, right? So I have created this new file called git.md. I made some edits to this git.md, right? Oh, it's not in the proper repo. Okay, cool. Great. So now let's have a look at our GitLab. Let's refresh it. Where is that git.md? I added, right? But it's not there. The reason is like we are only making those changes locally. So those changes are only sitting on your local computer. It's like it's not synced to GitLab yet. Okay, so let's have a look at this one. So these are some stages how you can have your code to GitLab. And so this is your machine. So what we have been working on is called working directory. So this change is made on your working directory, like locally, only on your laptop, nothing else. So your changes, your play with the code, anything you make change will not have impact on other people's repo. Like for example, you have like a project, right? It's a working software. There are users who are using the code, right? They are using your project. And you are making some changes. Maybe you are fixing a bug, you are adding some features, maybe you are just playing with it. So your change will not have direct impact on the project for people who are actually using the project, using the product, the software. So your change, your edits, your playing with the code only sits on your own computer. And it will also not having any impact on your team members' work. It's only sitting on your own computer. So this is the working directory. And this is the remote repo, which is what we see on GitLab here. So this is the remote repo, remotely at GitLab. So that's the remote repo. So everyone on the team who have access to the project sees the same for this one. And in the middle, there are a few different stages. One is called staging area, the other one is called local repo, and the other one is called remote repo. So why do we need those different stages, right? Why do we need those? Let me show you something. So for example, you made one git.md. Well, in the meantime, you wanted to do some different features. For example, you may want to have, you want to make an announcement about week1.md. So this is something else. They are unrelated to each other. So week 1, what we are going to do, practicing Git, kickstart project, form groups, right? So you make changes to different things. So for your project, for your software, maybe there are different features. One is about user login. The other one is about fixing a specific bug, right? And you feel like, well, Git, this one, I'm not done yet. I'm still learning. I may add more like Git other commands. But week 1, I feel like, that's not the main focus for this week. I've already done the list. So you can only push this one, this change, to the remote repo, while leaving this one behind. You can push that later when you feel, well, that's ready. I can push that to remote repo to share with my other team members, or make it available to use for my users. You can leave that for later. You can do this by, how you can do that? You can do that by using git add, and I'm only adding week1.md. So only week1.md is git add. So what that means is your change about add new git.md. So this change still sits at your working directory, while your another change, which is at week1.md, has been git added from your working directory to staging area. However, when you check the remote repo, are you going to see the week1.md? Not yet, because they are still sitting at staging area. It's not pushed to GitLab yet. Okay, so you have a week1.md, and then you feel like, oh, all right, I feel like for week 1 there's something missing. I wanted to have another file about this feature. For example, I want to have like a kickstart code, kickstart.md. This is also about week 1. Like, it's about the same feature, but I want to separate them in different files because they are doing different things. For example, I will say kickstart file will have some Python code to familiar with. Okay, so I want to put them together as a package because they are about one feature, about one theme. So what you can do is you can add the kickstart.md. And now on your project, you will have two things. Add kickstart.md. So both of them are now at the staging area. And then if you have other changes to make, feel free to do that and then just git add them. And when you feel, well, this is ready now. So everything about week 1 is there. I'm happy to make them a package, take a picture of them and say, well, all these changes are about week 1. About one single feature, one same feature. So how you can do that? You can use git commit. Git commit will move those at the staging area to your local repo. And you need to give it a commit message so that in the future, like 1 week later, 1 year later, or even 5 years later, you know what you were doing. Okay, so let's give them a message. So what I've been doing here, so all this at week1.md, at kickstart.md is about things to do about week 1. put the master package. And there will be a long message here. So I'll go back to that later. So now both of them are packed together and moved to local message and local repo. And there's also a commit message about things to do for week 1. Okay, so this is ready now. So they are all here. So all these 2 changes and this message, they are together. Now, I think they are ready for other people to know about my change group, like this group of change. What I can do is I can use, tell me, git push. Right, so what you can do now is you can use git push. It will ask you for a passphrase, which is just your pin. And then when you refresh your GitLab, you will notice kickstart.md, week1.md are on your GitLab now. And they have a commit to it, and they share the same commit, which is things to do about week 1. Yeah, question? Why do we need git add?
Because you can just save the file.
Uh-huh. That's a very good question. Yeah, why do we need git add? Any thoughts? Yeah, one by one, sorry. 2 people talking. Yeah, do you want to start first? Lady first?
Yes, because you have to add the file, so it has to know what file it is.
They need to know which file you want to pack, like put into the package. Because if you only have git commit, they don't know which change you wanted to commit or put into the package. If you don't have this staging area, you start from here. You have git add a new you have add new git.md, add week1.md, add kickstart.md. But they are about different things. And you commit them all together, it will be very messy. And other people will be very confused, like, what are you doing here, right? Like all the changes are together. I don't know what's your purpose, what's your goal here. And when long time passes, like when you go back to your project, you will also have no idea what was I doing. Right? So you want to put relevant things together as one commit, rather than put all changes together. Because you may work on like, I've make some changes to Git, and then you realize, well, there are some other things I want to change, although it's about another feature. You create another file, make changes to here and there, here and there. But in the history, you wanted the history to be clear. Like commit message or commits is like history. It's like the history of your project. So for example, let's have a look at here. Let me click on the last commit. You can see all the commits here. Where's my commits? Code commits. Yep, you can see all the commits that you have made. And the first one was the initial commit where we kickstart the initial project. So that's automatically created for us, the initial one. And the second commit is about things to do about week 1. And when you click on that, we'll see there are 2 changed files in this commit. And what are the changes? So it's very clear which, like what changes you have made, like the history is very clear. So this is why we need a staging area. Any other question? Yep.
What if we add like a wrong git add or anything that is inside the file that we git added without changes?
The question is, what if we accidentally added something that doesn't belong to the package or thing? I will leave this question to all of you. Do the research yourself after the lecture. Homework, yay. Any other question? So something to think about after the lecture, which is great. Anything else? Okay, cool. So where are we? So let me go back to the slides. So this is how we start from like GitLab start a new project, git clone it to local repo, and then make changes locally, package them, add them, commit them, push them. Okay, so this is what we have learned so far. Another important Git command to learn is called Git status. So Git status shows the status of your Git repo. For example, here, when we use Git status, it will tell us we are on branch main. I will explain what that means later. And there are also an untracked file, which is the git.md. Remember that this git.md is still at working directory. Working directory is not tracked by Git yet, so it's never been Git added, Git committed, nothing. It's not tracked by Git yet. Nothing else, so nothing added to commit, so nothing on the staging area. So you can use Git status to check the status of your Git repo. Okay, well done, congratulations. So now you have learned how to use Git on a single machine. So now the question is, what if sometimes you work on the project on your own laptop at home, sometimes you work on the campus on the computers from the school, like the school computers. How can you do that? So now this is, let me push this git.md as well. So there's nothing untracked. Git.md, git commit -m, initial git.md, and then git push. Yep, perfect. Let me double check my remote repo. Great, it's here. So now, what if we are working on different machines? The question. Have you ever used the Tiger VNC? The CSE? Oh, never. Okay, no problem. So quickly explain what that is. So Tiger VNC is a CSE server machine. So I've logged in on Tiger VNC here. It's like I'm controlling a remote machine on my computer. You don't need to worry about that. So this is just for demonstrating purpose. So I don't have two computers now, so I'm using a remote machine to demonstrate. So now I'm on a remote repo. I'm on another computer. So now I'm not on my own computer, right? So this is, I'm using Tiger VNC to control another machine sitting at CSE building. So this is what I'm doing now. So imagine that I'm on another computer. Okay, so so to work on this project, I need to know where this project is, right? So the URL of this GitLab repo. Let me Control C to copy. Open the browser. Control V. Oh my goodness. Sorry. This is complicated. Okay, to make things easier, so we are not wasting time on this one. So what I'm going to do is, okay, so you can see can you see from the back, is it too small or is it okay? Back, can you see my screen? Okay, I'll make it larger. How can I make it larger? Okay, is it better? The other one is not loading. But what you can do, how can you copy the project from GitLab to your local repo? Git clone, yes. Git clone, and pass it here, put in the passphrase. Amazing. So when I list, you can see there's a new project that is like downloaded on your remote, on the other machine, right? So now I'm working at CSE. I'm on a CSE computer. Let me cd do this welcome dash and then code to open Tiger to open Visual Code Studio. Great, so you can see that although I'm on another computer, I also have access to this project. I can see all the files here. Any question here about why I can see all the files on another computer? Because I git cloned it, right? Cool, so now I'm working at CSE. I want to make some changes to it. So now we have learned git clone. What else have we learned about git? From the back? Anyone from the back? What have we learned? Can you remind me, please? I forgot. Git add. What else? Git commit. What else? Git push. Perfect. So this is what we have learned. Amazing. So I make those changes on a CSE machine now, right? So now I have finished my work at CSE lab. I'm going home. What should I do now? I need to, yep, anyone from the back? Sorry. What should I do now? I finished my work. Da, 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 da. Anyone from over there? Git add, yes. Git add followed by the name git.md. Next, git commit. Okay, now I have a question. Can anyone give me a commit message? Can anyone give me a commit message? Anyone from the left-hand side? Sorry, I can't hear. Add git.commit. Yes, so this is a good one. So when you write commit message, make sure that your commit message is meaningful. It carries something, not just, for example, fix bug. Who knows what do you mean by fix bug? What bug, right? Or add new feature. Like what feature, right? Or something like random, commit random. Who knows what that's random? So that's not a meaningful history. Right? So when you write commit message, make sure that it carries some meaning. So when people read that commit message, people knows what you are doing here. Okay? So what's next? Next. Last one. Push. Yes, perfect. Git push. I know you are tired. Almost 8 p.m. So late. Okay, so now I've done my work on CSE machine. Now I go back home. I refreshed my remote repo. It looks great. So I've got all the changes that I made at the CSE machine. Now I want to continue working on this project. However, when I open the project locally, it still only has git clone. Why? Because those changes are sitting at a remote repo. To get it from the remote repo to our local repo, there's a new command called git pull. Okay, let's try it. Things ready. Magic. Look at my screen, okay? Look at the screen. I'm going to use git pull. Ready? Everyone ready? I'm hitting return. Oh, password, sorry. Yay! Magic. Did you see it? So using git pull, we are pulling the changes from remote repo to our local repo. So this is the first thing you need to do when you go back home, before making any new changes. Right, git pull. What if you forgot to git pull? And you made some changes and you didn't say git add here, you said like something different, like I learned git pull, I learned git something randomly, oh, blah, blah, blah. What will happen? Let's have a look. Okay, so what if that happens? Don't worry, you can still solve that problem. Okay, so when you accidentally, so let me make some changes here for now. So let's say, what's the new git command we just learned? Git pull, right? There's another git command we actually have learned but haven't added here yet. What's that? Status, perfect. So let me git add git.md and then git commit. Can anyone give me a quick commit message, please? Add pull and status to git.md. So it's very specific, right? So what are the changes that you made? And then let's git push. Great, so I finished my work at home. And now, second day, I'm on campus. I'm on CSE machine again. But I forgot to git pull. And I make some changes to my git.md. So silly me forgot pull. So this is the change I made. And I also make some other changes. For example, I deleted something. Okay? And then I finished my work. I feel like, oh, I'm so smart. I did the most perfect thing in the whole wide world. And then I git add git.md and I git commit silly work. And then I git push. What's going to happen? Let's have a look. Ta-da! Rejected. So GitLab rejected your push. It says that failed to push to Updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same reference. If you want to integrate the remote changes, use git pull before pushing again. So actually Git is so helpful. It tries its best to help you, give you a lot of hints. So let's just follow their hints by using git pull. What's going to happen? Ta-da! Let me put in the password. Okay, did you see the change here? So this is what Git did for you. So it pulls the remote changes while keeping your local changes. It helps. So I was worried, like, what if I deleted your local changes, but those local changes are very important for you? I don't know what to keep for you, right? So what Git does, it keeps all the changes you had here, but also pull the remote thing from the remote repo. So it puts everything here for you. And all you need to do is to delete the things that you don't want and keep the things you want. So I don't want to keep the silly me. These things I can just delete and delete. So this is actually what I want. Save the file. Go to here. Let me git status to double check everything okay. Did I pull properly? Okay, let's git. So I'll fix the problem. Git.md git commit -m. The commit message will be fixed silly me conflict. And then let me just pull again to double check. Okay, perfect. Everything all good. So let me git push. Great, problem solved. So if in case you forgot to git pull before making changes, don't worry, you can still solve that problem. And this is called conflict, called merge conflict. So this is conflict not happening between people, but between the code, in the code base. So this is how you can solve the conflicts, the merge conflicts. Any question about the merge conflict? Oh, someone said there's no audio suddenly. What's going on here? That's bad. Testing, testing, can you hear me now? Sorry, 1 second, I'll just fix the audio from online. Testing. Okay, perfect. Someone can hear, someone cannot hear. Okay, that's interesting. Okay, anyway, let's keep going. Thanks for confirming. Thanks, everyone. Thank you. Okay, any questions so far about the merge conflict? All good? Yeah, question.
Yeah, do merge conflicts only happen when you change an existing file or if you add a new file?
The question is, will merge conflicts happen when we change the same file, or will it also happen when we add different files? What do you mean by add different files?
Like for example, if you create a new empty file.
So what if we create a new MD files? It's okay, it will merge for you. So Git is quite smart. Unless there's some conflict that they cannot solve, it will solve it for you. Yep. Another practice to do for your lab-git that lab to practice. Cool, amazing. So that's about how we can use Git on a single machine by multiple machine by a single person. So now the question is how we can actually use Git for our team. So this is actually what we really wanted, right? So we wanted to code concurrently. We wanted to collaborate with others on our code projects. How can we manage our software project using Git? So Git is actually primarily useful when working with others, and working with others effectively is very important. So here we are going to introduce another new topic called branching. So this branching thing may be a little bit confusing at the beginning. It's very, very common. If you don't get it in the next 10 minutes, no problem, no worries at all. It's very common. Use the lab to practice, and you will get better understanding about it. So a lot of things about software engineering is like practice. So only listen to the lectures or watching me doing it may not make that much sense for you, but when you actually practice yourself, you will know what that means. Okay, so now the Git tree model. So Git can actually be understood as a tree-like structure. What is that? Try to get as much as you can in the lecture, so when you use the lab, it will be easier for you. Okay, so the branch that we have been working on so far is called main or master. So some projects, they use main, some use master. So if you see main or master, don't worry, like although I say master here, but in your Git project, you will see main. But they are just meaning the most important branch, like all the working code should be there. You shouldn't put any broken code in main. But if you want to have a new feature, or you want to fix a bug, like you are actually changing the code, it's very often that the code, because you are making changes to it, right, it's quite okay that it's not perfect. But you don't want to disturb the main branch. So what you can do is you can create a new branch, like starting from the main branch as a specific commit. You check out to a new branch, and you work on that feature. And you do not need to worry about the main being like impacted by your non-perfect code. So the main is still main, right? But you check out to another separate branch, and you work on your feature. And you feel like you tested the feature, everything works, like the new feature, you feel like it's ready for it to be merged into main. You can then merge this feature branch to main. Does that make sense? So for example, now what we had in the project was we have git kickstart.md, read.md, and week1.md. And now I want to have a new feature called project. And I'm afraid that adding this new feature will have, make the main branch not working perfectly anymore. What I'm going to do is I'm going to check out. So create a copy of the current main. So check out to a new branch means create a copy of the current branch. So let's have a try so you have better understanding of what I mean. So before I do anything, I need to git pull first. Remember that? Yep. So let me git pull first. Perfect. It merged automatically for me. So Git is very smart. It will merge for you wherever it can. But when there's something that really conflicts, they don't know what to keep, what to delete, it will ask you to make the decisions. Okay, so now let me git status to double check. So you can see that I'm on branch main. So this is the original branch that was created by GitLab when we init the Git project. So now I wanted to check out to a new branch, which means that I'm going to create a copy of the current repo on a new branch so that I can feel free to make changes to it. So the new command that I'm putting here is called git checkout -b, and then give a name for it. So here are some examples. Oh, hey, there's new branch, it's just new branch. Okay, so let's call this project info branch. So naming the branch is also important, like naming your commit message. So your branch name should also carry some meaning. Okay, so you can see that we are now switched to a new branch called project info. Yay! So let's have a look here. So you can see that it still has everything. So although we are now on a different branch, it also has all the files that we had from the main branch. And then you can make changes on this new project info branch. So for example, I can have a project.md. I can say our project is about task tracker. Okay, so I made some changes, but this change is only made on the project info branch. It's not made on the main branch. So let's check. So to go back to the main branch or go to another branch, you can use git checkout main. And you can see there's, where am I? Why this project is here? Oh, weird. Huh? Visual Code Studio does that. Did that for me. It shouldn't be that. Let me double check. Git status. I hate you, Visual Code Studio. I don't want that. Okay, so let me double check. I must have done something wrong. Git checkout, switch to a new project, switch to let me double check. Yeah. Yeah, untracked because I've never git add that project.md on any branch. Let me git check out project info, switch to the, I hate you. Okay, I didn't push, so checking there doesn't make sense, right? Anyway, so this shouldn't be happen. It must be something wrong with my Visual Code Studio. I'll double check for that. So it may be also a great opportunity for you to explore this week using your lab again. And then maybe some of you can tell me how this happened, but this shouldn't happen. Yeah. Anyway, let me check again. So git checkout project info. So we are now on project info. Let me test. I'm on this project info. Sorry, 1 second. Git checkout main. How about we close it and git check? Just in case it was Visual Code Studio doing the stuff. Git checkout project info. And then blah, blah. And then I git checkout main. Still there. That's so weird. Anyway, so what git checkout -b means that you are creating a new branch. So I'll figure out what's going on here. But normally, what it should happen is that when this branch is ready, like when this feature is ready, you can merge this branch into main. And the way that you merge a feature branch into a main branch is through peer reviewing. The reason is because merging any code into main needs to be double checked. Okay, so let's have a git. Sorry, I know it's a little bit over time, so if you need to leave, feel free to do so. I'll just do another 5 minutes and that's it. Sorry, check out the wrong one. Git checkout project info. And then let me git status on what are changes here. So I git add project.md, git commit -m, add new project. I'll quickly do it, .md, and then git push. So there will be an error message when we git push on this new branch. It says that the current branch project info has no upstream branch. To push the current branch and set the remote as upstream, use blah, 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 blah. So the reason is on our remote repo, there's only main branch. There's no project info branch yet. So when we push the project.md onto the project info branch, they don't know where to push it. Because on the remote GitLab repo, there's no that branch yet. So GitLab is again trying to help us. So it actually tells us what we need to do. So let's just copy and paste here. So git push, set upstream origin project info. It asks for the passphrase. Amazing. So now when we refresh here, you will notice that other than the selected main stream, there's also another stream called project info. Okay, and automatically there will also be something here. So you push the project info just now, asking whether you want to create a merge request. So the merge request means that it's asking whether your project info branch is ready to be merged to main or any other branch. So this merge request from a feature branch to the main branch needs to be done on GitLab GUI. Let me show you how to do it. So create merge request, and then let's create a title for this merge request. Create new project MD as the new project feature. So you can also describe what do you add. You added this file called project.md. There may be other things that you delete. I don't have anything here. Blah, blah, blah. And you may have other changes that you made. So you can describe this merge commit because merge request, because this merge request is even more important than a commit message because it's like a more bigger building block. It's about one feature, new feature, or fix a new bug. It's bigger than one commit message. So in one merge request, there may be multiple commit messages. And you assign another people to review it. Because in this project, I only have myself, but in your group project, you will have your group members. Select one of them as reviewers, asking them to review this project, and then create this merge request. Ready to merge. So Your team members' job is to review your merge request, making sure that your feature is ready, your bug fix is ready, your branch is ready to be merged into main. It's safe to do that. So this is the role of your team member, the reviewer. But you need to merge the merge request into main yourself. So you are taking responsibilities of your code. So your team member's role is to help you to review, to double check, give you feedback, but your job is to actually merge it. You can also leave comments here to interact with your team member. Your team member may say, oh, can you change something, or can you add something? So you can give feedback, peer review in this way. So now when we go to the mainstream, you will notice that there's also this project.md on the remote repo. Okay, sorry about the delay, the extra 4 minutes. So this is everything about team usage. Use the lab to practice. Use the lab to practice. Practice, practice, practice. And you will practice merge conflicts, branching, everything. Any question, put on the forum, and we'll help you out there. Okay, thank you. Thank you so much. Thanks. Sorry, I'll just